Ever heard of a billion-dollar project that failed simply because someone forgot to do the math? From iconic bridges to high-tech manufacturing systems, even brilliant engineering feats can crash and burn if they don't make economic sense. So, what separates a great idea from a viable investment? Enter the 10 principles of engineering economic analysis. These principles, based on the foundational text, Fundamentals of Engineering Economic Analyses, First edition, Wiley Inc., aren't just academic theory. They're practical tools that engineers, analysts, and project leaders use to evaluate the economic performance of systems, investments, and technologies. When applied correctly, they can help drive smart investments and long-term success. But what happens when these principles are ignored? How bad can the fallout be, and what can we learn from it? Let's find out. Welcome back to the channel. In this video, we'll give you a brief overview of the first 5 principles, each paired with real-world success stories and cautionary tales to bring them to life. We'll dive deeper into each principle and introduce useful tools like net present value, lifecycle cost analysis, and risk modeling in upcoming videos. And don't worry, principles 6 through 10 are coming in part 2, so be sure to subscribe and turn on notifications so you don't miss it. By the end of this video, you won't just design better, you'll think like an engineering economist. Full citations and links to every source are in the video description. Let's get started. Principle 1. Money has a time value. Would you rather have $1,000 today or $1,000 a year from now? Of course, today, because a dollar today is usually worth more than the same dollar tomorrow. This is called the time value of money, or TVOM. To understand why, let's look at 2 very different real-world examples, one that shows this principle working in your favor, and another that reveals its dangers. Positive example: the U.S. long boom, 1945 to 1973. After World War II, the United States entered a period called the long boom, lasting from 1945 to 1973. This was a time of sustained economic growth, low inflation, rapidly increasing productivity, and steady stock market gains. If someone had invested $1,000 in the S&P 500 stock index in 1945 and reinvested all dividends, by 1973 that investment could have grown to over $23,000. That's the time value of money at work, compounding interest and earnings, growing your wealth over time. Negative example: the 1929 stock market crash and buying on margin. Let's flip the script and look at what happens when the time value of money goes wrong. In the late 1920s, the U.S. stock market was on fire. The Dow Jones Industrial Average increased 6-fold from August 1921 to September 1929. Everyone, from Wall Street bankers to everyday Americans, wanted in. But many didn't use their own money. Instead, they were buying on margin, borrowing up to 90% of a stock's value, betting that future gains would more than cover their loans. In essence, they were borrowing against tomorrow's profits, assuming markets would always go up. But then the market crashed. On October 28, 1929, a day that became known as Black Monday, the Dow declined nearly 13%. The following day, on Black Tuesday, the Dow dropped another 12%. By mid-November, the Dow had lost nearly half its value. Stock prices plummeted and margin calls flooded in. Investors were forced to repay loans instantly, even if it meant selling everything at massive losses. Over the next 3 years, the Dow Jones dropped nearly 90%, and countless investors were financially wiped out. But the pain didn't stop there. The crash triggered the Great Depression, a decade-long economic collapse. Prices fell, deflation set in, making each dollar more valuable. But at the same time, wages dropped. Unemployment surged past 25%, and credit dried up. That meant future money became more valuable and a dollar could buy more, but no one had money and debts didn't shrink. In fact, deflation made it harder to repay loans, especially those taken on margin. People owed yesterday's inflated debts using today's scarce, harder-to-earn dollar. This is the dark side of the time value of money, when you bet on future gains to pay off today's debt, and those gains disappear. You're left with rising obligations and no way to meet them. Time changes money's value. Sometimes it builds wealth, other times it exposes risk. Smart engineers and economists understand how to navigate both sides. If you would like to learn more about the time value of money, or TVOM, click on the linked video. Principle 2. Make investments that are economically justified. Should you spend $20,000 on a robotic welder that saves $10,000 per year in labor over 5 years with all other costs being negligible? That's an easy yes, because the benefits clearly outweigh the costs. This is an example of economically justified investment principle. This principle is about spending capital only when the expected returns, financial, operational, or strategic, justify the investment. Let's look at a real-world success embodying this principle, as well as real-world missteps when this principle is not followed due either to an underinvestment or an overinvestment. Real-world success. Amazon's investment in warehouse robotics, 2012 to present. In 2012, Amazon acquired Kiva Systems for $775 million, buying automation technology that revolutionized its fulfillment operations. By 2014, these robots reduced pick-and-pack cycle times from around 60 to 75 minutes to 15 minutes, and cut operating expenses by approximately 20%, equating to about $22 million saved per fulfillment center. As of June 2025, Amazon has deployed over 750,000 robots across its operational network. Over the same period, Amazon's revenue shot from $61 billion, 2012, to over $640 billion, 2024, an almost 10 times increase, highlighting how smart automation investments deliver massive payoff. Real-world misstep. Nokia's late entry into smartphones, 2007 to 2013. Sometimes, failing to invest in the right innovation at the right time can cost everything. In the late 2000s, Nokia was the global leader in mobile phones. But as the market shifted toward smartphones, driven by Apple's iPhone and Android devices, Nokia stuck with its aging Symbian operating system and delayed major investments in competitive smartphone platforms. Then came the 2008 financial crisis, which hit global consumer spending hard. While the recession certainly impacted Nokia's performance, its slow response to smartphone innovation was just as damaging. By the time Nokia launched its Lumia line with Microsoft in 2011, it was too late. Between 2007 and 2012, Nokia's market value plunged by nearly 90%. The company, once worth over $200 billion, sold its phone business to Microsoft in 2014 for just $7.2 billion. This wasn't just a downturn. It was a strategic failure to invest in innovation when it mattered most. Real-world caution. Tesla's automation overreach, 2017 to 2018. On the flip side, investing too much too soon can also backfire. In 2017, Tesla tried to heavily automate production of the Model 3 at its Fremont factory. The plan was bold, but the reality didn't deliver. Robots frequently broke down, jammed, or slowed the process, leading to major delays. Instead of streamlining production, automation created bottlenecks. Tesla had to bring workers back in to get things moving, which added unexpected costs and complexity. These Model 3 issues greatly contributed to Tesla's 2018 Q1 cash losses. Even Elon Musk acknowledged the mistake, tweeting, "Yes, excessive automation at Tesla was a mistake. To be precise, my mistake. Humans are underrated." So what's the takeaway? Amazon's warehouse automation shows how economically justified investments can unlock massive gains in speed, scale, and revenue. Nokia, on the other hand, shows the danger of waiting too long. Failing to invest when it matters most can cost you your market position. And Tesla proves that even cutting-edge ideas need to be justified by the numbers. Over-investing without clear returns can be just as risky. Smart engineering economics isn't about spending more. It's about knowing when and where the spending makes sense. Principle 3. Choose the option that maximizes economic worth. When making engineering decisions, the cheapest upfront cost isn't always the best choice. Principle 3 encourages choosing the option that creates the greatest overall economic value over time, factoring in all costs and benefits. Real-world win. Toyota's investment in hybrid technology, 1990s to present. In the late 1990s, Toyota made a bold decision to invest heavily in hybrid technology, developing the Prius, the world's first mass-produced hybrid car. At the time, hybrids were more expensive to design and build than traditional gasoline cars, and many doubted their market appeal. But Toyota did the math and bet on long-term benefits. The Prius launched in Japan in 1997, and globally by 2000. This $1+ billion investment in research and production paid off handsomely. By 2020, Toyota had sold over 15 million hybrids worldwide, saving customers billions in fuel costs and gaining regulatory advantages. Real-world misstep: San Francisco-Oakland Bay Bridge replacement. Contrast Toyota's investment with the San Francisco-Oakland Bay Bridge replacement project, which began in 2002. To save money up front, officials awarded contracts based on the lowest initial bids, selecting international contractors with limited experience in seismic engineering. This cost approach, known as price-based selection, PBS, can be risky when dealing with complex engineering projects like bridge construction, where long-term durability and safety are paramount. Over the next decade, the project faced numerous problems: faulty welds, cracked bolts, water leaks, and major delays. Originally estimated at $1.4 billion, the bridge's final cost ballooned to over $6.4 billion when completed in 2013. Toyota's hybrid bet paid off because they focused on long-term economic worth. The Bay Bridge, on the other hand, showed what can happen when decisions are made based on the lowest bid alone. Tools like life cycle cost analysis, net present value, NPV, and return on investment, ROI, can help engineers and decision-makers identify which options truly maximize long-term value, not just short-term savings. We'll cover these tools in upcoming videos so you can make smarter, data-driven engineering decisions. Principle 4. Equivalent alternatives have equal economic worth. Different financial options, like leasing versus buying, can yield the same economic value when you account for all associated costs over time. This includes maintenance, taxes, depreciation, and opportunity cost of capital. The key is to use financial tools like net present value, NPV, and discounted cash flow, DCF, to compare them fairly. Don't worry if those terms are new. You can check out the linked videos to learn more about them. For these examples, all you really need to know is that they are calculations that can help you make smart financial decisions. Positive example: UPS, smart use of leasing versus buying. According to December 2024 reports, UPS operates a global fleet of approximately 128,000 vehicles. Choosing not to buy all these vehicles outright, the company instead uses a mixed acquisition strategy, buying some vehicles while leasing others. According to the company's annual reports and third-party analysis, this approach is based on thorough lifecycle cost modeling and NPV calculations. By leasing specific types of vehicles in certain markets, UPS gains the following: 1. Lower upfront capital outlays, freeing funds for other projects. 2. Tax benefits from lease structures since lease payments are often fully deductible. 3. Flexibility to modernize or scale its fleet, especially with electric vehicles. This strategy enables UPS to remain agile, efficiently reduce emissions via modern vehicle integration, and deploy capital where it's most impactful. Negative example: Hertz, overexposed by fleet ownership. On the other hand, Hertz built its fleet strategy around vehicle ownership, primarily financed through asset-backed securities, ABS. This model allowed Hertz to borrow at lower interest rates by using its vehicles as collateral, which was generally cost-effective in stable times. However, this model also meant Hertz was locked into large debt obligations, regardless of business performance. When the COVID-19 pandemic hit in 2020, travel demand collapsed and rental revenues plummeted, dropping by over 70% compared to the previous year. Despite the sudden downturn, Hertz still owed regular payments on its 500,000-plus vehicle fleet. With used car prices temporarily depressed and refinancing options limited, Hertz couldn't sell off assets fast enough to meet debt obligations. The rigid ABS structure left little financial flexibility. In May 2020, Hertz filed for Chapter 11 bankruptcy, seeking to restructure nearly $19 billion in liabilities. Bottom line: never rely on surface-level cost comparisons. Use tools like NPV, life cycle cost analysis, and risk-adjusted modeling to reveal the true economic worth of your choices. UPS used DCF tools to find value in both leasing and buying, aligning strategy with financial and operational goals. Hertz, by contrast, overcommitted to ownership without fully accounting for systemic risk, and it paid the price. Subscribe to the channel and check out our other videos in which we talk about these topics in more detail. Principle 5. Marginal revenue must exceed marginal cost. When deciding whether to produce one more unit, remember this fundamental rule. Only proceed if the additional revenue gained exceeds the additional cost needed. Real-world win. Micron's Wafer-Start reduction. 2022. In 2022, as global demand for memory chips declined after the post-pandemic surge, Micron Technology made a strategic adjustment. Instead of continuing high-output production, the company cut DRAM and NAND wafer starts by roughly 20% compared to the previous quarter. Wafer starts, the initial stage of chip manufacturing, determine future supply. By reducing these items, Micron avoided overproducing low-margin chips during a demand slump. Company leadership described the move as necessary to significantly improve total inventory and stabilize pricing. This was a clear application of marginal analysis, halting production that would generate less revenue than cost. In doing so, Micron protected profit margins and demonstrated how smart supply control can support long-term financial health. Real-world misstep. HP's TouchPad overproduction 2011. Back in 2011, HP rushed into the booming tablet market with the TouchPad, aiming to compete with Apple's iPad. Confident in high demand, they produced large volumes up front. But sales were dismal. HP sold a fraction of the tablets they initially expected, with reports suggesting that Best Buy, for example, sold only 25,000 out of a shipment of 270,000 units. Rather than pausing production, HP kept building. Inventory piled up, unsold. Within weeks, they pulled the plug on the product and slashed prices to $99, far below the production cost of about $300 per unit. This significantly contributed to HP's $885 million write-down on WebOS and hardware losses in Q4 2011. HP violated the marginal principle. They kept producing units where the marginal cost far exceeded marginal revenue. The more they made, the more they lost. These two examples show that more isn't always better. If the cost of producing one more unit outweighs the revenue it brings in, you're not benefiting, you're bleeding money. That wraps up the successes and failures for the first 5 principles of engineering economic analysis. These principles help engineers go beyond just technical specs, encouraging decisions that create long-term economic value. And this is just the beginning. In part 2 of this series, we'll explore more real-world examples using principles 6 through 10 to show how these concepts shape successful and not so successful engineering outcomes. If you know of any projects, good or bad, that relate to the principles we've discussed today, drop them in the comments. We'd love to include them in future videos. And as always, don't forget to like, subscribe, and hit the bell so you're notified when part 2 goes live. Thanks for watching. Remember to design smart, think economically. See you in part 2.